Hello, I'm Dr. Levon Hairapetyan, a business professor at Houston Baptist University. In this video tutorial, I will show you how to do k-means clustering using analytic solver. And I will demonstrate it on the example for a company called KTC. This company is a financial advising firm or company which creates financial advising plans for its customers. So they want to have some tool which will allow them to create a financial plan for just new customers. In order to do that, they decided to use cluster analysis, and they decided to use divide the information into 6 clusters, and the information is in here, information about their current clusters, current customers. They have 30, and this is the information which they have on each customer: age, sex, income, married or not, the number of children, whether loan or not, and mortgage or not. So based on this information, they decided to divide this set into 3 clusters. And when a new customer asks for a plan, they can see which cluster is more appropriate for a new customer, and then create a plan based on that, on the characteristics of that particular cluster. So let's show me how to do cluster analysis. By the way, everything which I will do, it step by step is described also on slides in the PowerPoint presentation, which is posted on Blackboard. So the first thing is you click anywhere inside of the data set, go to the data mining, then go to the clusters. We did the same steps, these beginning steps, when we were doing hierarchical clustering. Now we'll do k-means clustering, and then we will decide which values are we selecting. So we will select age, income, and number of children. So company decided that these are 3 critical information which they want to use to cluster their data. Well, as I mentioned several times, one of the first things which you have to check is make sure that your data range is correct here. And it is correct. By the way, if it's not correct, then you will click here, and then you will highlight the range, the correct one, like this way. And click OK. Then, since our data contains, the headings are in front, the first row contains headings, so we will leave this. So we are done with this first step. Click Next. Here we have to decide whether we want to normalize or not. Remember, we do normalization when the scales of the values are very different, and there is a large scale difference. And we have this situation because number of children are in small numbers and the salaries are in tens of thousands. Therefore, if we do not normalize, the salary, the variable will be very dominant. So we'll click Normalize. Then we'll specify how many clusters we want, 3. Let's leave number of iterations, 10. So here's this is what we'll do in here. When we leave the way it is, which is fixed start, it means that we're asking solver to randomly generate 3 clusters and then start k-means clustering process. However, there is another better way of doing it. We can click random starts, and we can specify, let's say, 10 random starts. And this seed is just where the random numbers will start generating. So just leave the way it is. What does this mean when we put 10 in here? It means that software will generate 10 random clusters, triples of clusters, and for each of them, they will calculate those distances, and whichever is the best, which means whichever generates the smallest distance, they will use that starting point. So instead of starting just from the first random one, they will do that 10 times, and we will select the best. which is better choice, obviously. Then we will click next. Let's leave these boxes checked, which means we want to see the data summary and we want to see also distances, and we'll click finish. So software completed the job and it created two tabs here. One is called KMC, which stands for K means clustering, and this is output tab. So which information we'll get in here? Let me just scroll down. By the way, explanation, everything which I will explain in here and much more are done on slides as well. Not in the textbook, but on slides. So here, remember we selected 10 random starts, and these are the start 1, start 2, start 3, up to start 10. And for each start, they calculated sum of square differences. And then whichever is the smallest is the best. And see, they figure out that the best is the third start, which means, and that's what, pay attention. This is sum of square differences, 81, 51, 49, the smallest number is this. So they will use this random starting points. So this is where they will start k-means clustering. Let me scroll down and see more what we have. So these are, so they created, software created 3 clusters, and these are the centroids of those 3 clusters. So this is the centroid of the first cluster, second cluster, and the third cluster. Now, by looking at this data, and remember these are normalized data, what we can make sense of this data. Look at this. Let's start with cluster 1. What are the characteristics of the cluster 1? If you look at age, then this is the smallest number in this column, which means cluster 1 consists of the youngest people. Look, income column. This number is again the smallest, which means that the smallest income, and this value in this column is the largest. Therefore, the characteristics for cluster 1 will be the youngest people with the lowest income and the most number of children. That's the characteristics of the first cluster. Second cluster will be, see, this is the largest number in here, which means the eldest people, and income is, this is the largest number, that means with the highest income, and this is somewhere about average number of children. And finally, cluster 3 is somewhat average age people, and the income is probably somewhat below average, and the smallest number of children. So basically, by looking at these numbers, you can make sense of the actual, and judge about the characteristics of each cluster, which people are involved in or included in which cluster. In this part, which says intercluster distances, this specifies distances between cluster centroids. For example, this is the distance between centroids of cluster 1 and cluster 2, between cluster 2 and cluster 3, and so on. So and down here, these are the average distances. These are our 3 clusters. We have 15 observations or 15 customers in cluster 1, 5 customers in cluster 2, and 10 customers in cluster 3. And these are the average distances within each cluster. So what is the smallest distance? So the smallest distance, average distance is this. That means small distance means they are more closely, more similar, which means cluster 2 is the most homogeneous cluster among those 3. Whereas this is the largest cluster distance. That means the cluster 1 is the most heterogeneous cluster among those 3. Well, now let's switch to this tab. I'll come back here and do some more. So on this tab, which says clusters tab, we will see these are these clusters are specified in here. Remember, we figure out that we have 15 in cluster 1, 5 in cluster 2, and 10 customers in cluster 3. So who are those customers? Right now they are listed as a record 1, 2, 3. So record 1 is in cluster, belongs to cluster 1, record 5 belongs to cluster 2. In order to better visualize which clusters, which records or customers are in which cluster, we can sort this. So I'm highlighting this. And then I'll go to data. And then I will sort. And I will sort based on clusters and smallest to largest. Now you can see that these are my all observations in cluster 1. I can highlight this way. And if you count, there will be 15 of them. And then we should have 5 clusters in 5 observations in cluster 2 and 10 observations in cluster 3. This is how you can explicitly list clusters, list customers in each cluster. One more thing which we can do with this is, remember, one of the tasks for the company was to, if new customers comes in, then how do we, which cluster is more close to that new customer, so they can, based on that characteristics, they can create a financial plan for that new customer. So let me switch to, I think I have an, okay. I don't, let me go and just open my PowerPoint. This is posted and all details are there. So let's see the example which I did on the, I want to do for you. Let's say we got, let me copy this and I'll paste here to work with. So let's say this is, so the new customer came, and remember we did this cluster analysis based on 3 data: age, so age, then income and number of children, and we normalize. So this is the first one is, let me just copy it because I copied as a test. So it will be 0.98, 79, 23, and then 2.73, 4159, 4159, and 1.19, 0912, 0912. So now I can delete this. So these are my, this is the age, and this is income, and this is children. Children. So this is my new customer. Remember why I have these small numbers for age, income. Remember they are normalized because I have to use normalized because the whole kmeans clustering was done with the normalization. So if I want to compare a new customer and find the appropriate cluster, I have to use normalized data. So this is normalized data. Now I want to figure out which cluster among these 3 is more appropriate for this new customer. And in order to do that, we will calculate Euclidean distance between this observation and each centroid, all these 3 centroids, and whichever distance is smaller means that this new customer is more close to that particular cluster. So let me calculate those distances. Remember the formula, SQRT square root of, I'm doing for cluster 1, 2 square plus income for income minus income here squared plus excuse me, plus for children is minus So the distance from this new customer to the centroid of cluster 1 is this number. I will do exactly the same for cluster 2 and cluster 3. Square root of, now for cluster 2, it will be this, minus h squared plus for income minus income squared plus for children minus children squared, and I got this distance, and finally distance from the new customer to this centroid of the cluster 3 will be equals square root of h minus h for the third cluster squared plus children minus squared plus, second was income, now children minus children squared. So what we did is, here I calculated distances from this new customer to the centroid of these 3 clusters. And as you can see, that this customer is more close to cluster number 2 because this is the smallest number among these 3. Now let's remember what was the characteristics of this second cluster. Characteristics was that these are the oldest people in that group with the highest income and somewhere above average number of children. So based on this information, KTC may come up or propose a financial plan for this new customer. So this concludes my video. Have a nice day. Bye-bye.